Imagine any perfect circle you can think of. It could be the top of your coffee mug, the wheels of a bicycle, or even the full moon in the night sky. Now, picture taking a piece of string and carefully laying it all the way around the edge of that circle. The length of that string is what we call the circumference. Next, imagine measuring the distance straight across the circle, passing right through its center. That distance is called the diameter. The magic of pi, written as the Greek letter pi, is that it connects these two measurements in a very special way for every single circle that has ever existed or will ever exist. The relationship is beautifully simple and always true. If you take the length of the string from the circle's edge, the circumference, and divide it by the length of the line across its middle, the diameter, you will always get the same number. That number is pi. It doesn't matter if your circle is as tiny as a button or as vast as a planet's orbit. This constant ratio is a fundamental property of our universe, a hidden code embedded in the shape of a circle. It's a number that mathematicians have chased for thousands of years, trying to understand its deepest secrets. Pi is approximately 3.14159, but that's just the beginning of its story. Let's think about how a circle is drawn. You can fix one point as the center and then draw a line that stays at an equal distance from that center point as it moves all the way around. This continuous line that forms the boundary of the circle is the circumference. It's a perfect, unbroken loop that never crosses itself. It has no beginning and no end, just a smooth, continuous path. This elegant simplicity is what makes circles so special, and is the reason why a single number, pi, can so perfectly describe a key aspect of their geometry. The line flows endlessly, always turning but never intersecting its own path. This fundamental idea was understood by ancient civilizations long before they had a special name for this number. They noticed that for any circular object they created, whether it was a wheel for a cart or the base of a clay pot, the distance around it was always just a little more than 3 times the distance across it. They might have used ropes or sticks to measure, but the pattern was always there. This consistent observation was the first step towards discovering one of the most important numbers in all of mathematics. It was a pattern hiding in plain sight, waiting for curious minds to explore it more deeply. Now we know that pi is roughly 3.14, but what happens if we try to write it down precisely? This is where pi gets truly fascinating. Pi is what we call an irrational number. This doesn't mean it's illogical or crazy. It means that its decimal representation goes on forever and ever without ever falling into a repeating pattern. You can calculate pi to millions, billions, or even trillions of digits, and you will never find a sequence of numbers that repeats itself in a predictable loop. It is an endless, non-repeating string of digits, a numerical journey with no final destination. This property makes pi fundamentally different from many numbers we use every day. Take a number like 1/3, for example. When you write it as a decimal, you get 0.33333, with the 3 repeating forever. This is a rational number because it can be expressed as a simple fraction. Even a number like 1/7 becomes a repeating decimal, 0.142857, 142857, and so on. Pi cannot be written as a simple fraction of 2 whole numbers. No matter how clever you are, you can never find 2 integers that, when divided, will give you the exact value of pi. This is the essence of its irrationality. Why is this the case? It goes back to the geometry of the circle. Trying to perfectly measure the curved line of the circumference using a straight line ruler, the diameter, is an impossible task. Imagine trying to perfectly tile a circular floor with square tiles. You will always have small, awkward gaps around the edges that you can never quite fill perfectly. The curved nature of the circle and the straight nature of the diameter are fundamentally incompatible in a way that can be expressed by a simple fraction. The relationship between them is destined to be an endless decimal. This discovery that pi is irrational was a huge moment in mathematics. It showed that not all numbers were as neat and tidy as we might have thought. It opened up a new understanding of the number system, revealing a whole new category of numbers that couldn't be pinned down so easily. This infinite, patternless nature is not a flaw, it's a feature. It's a reflection of the perfect yet infinitely complex nature of the circle itself. The endlessness of pi's digits mirrors the endless smoothness of the circular form it describes. So if pi goes on forever, how do we even begin to calculate its value? One of the earliest and most brilliant methods came from the Indian mathematician and astronomer Aryabhata, around the year 499 CE. He didn't just give an approximation, he provided a method. Aryabhata imagined a very large circle and then drew a polygon with many sides inside it, with its corners just touching the circle's edge. He calculated the perimeter of a polygon with 384 sides and found it to be very close to the circle's circumference. Through this, he calculated a value of pi as 3.1416, which was astonishingly accurate for his time. Before the formal discovery and use of pi, mathematics involving circles was much harder. People had to rely on rough approximations. If you wanted to build a round tower, you might know that the wall needed to be a bit more than 3 times the width, but you couldn't be precise. This made engineering and construction a game of trial and error. Without a reliable value for pi, calculating the area of a circular field, the volume of a cylindrical grain silo, or the distance a wheel would travel in one rotation was incredibly difficult and often inaccurate. The invention of pi provided a key, unlocking precise calculations for anything circular. The importance of pi extends far beyond simple geometry. It appears in all sorts of mathematical formulas that, at first glance, seem to have nothing to do with circles. It shows up in probability, in statistics, and even in physics when describing waves, like sound waves or light waves. The path of a river as it meanders across a plain, the shape of a water ripple, and the principles of alternating current in our electrical grids all involve pi. It's as if the universe has a soft spot for this number, embedding it in the rules that govern how the world works, from the microscopic to the cosmic. The quest to calculate pi has driven mathematics and computing forward for centuries. Each new record for the number of calculated digits of pi is a testament to our growing computational power. While we only need a few dozen digits for the most precise calculations in physics and engineering, the challenge of finding more digits pushes the boundaries of our technology. It's a benchmark for computer hardware and algorithms. This ancient mathematical puzzle continues to be a driving force for modern innovation, starting with brilliant minds like Aryabhata and continuing with the supercomputers of today. You might think pi is something you only encounter in a math class, but it's actively working all around you in your daily life. Every time you check the time on an analog clock with hands, you are looking at a device whose design depends on pi. The gears inside the clock are circular, and their sizes and the number of teeth they have were calculated using pi to ensure they turn at the right speed to keep time accurately. Without pi, designing the mechanics of a simple clock would be a frustrating guessing game, and our timekeeping would be far less reliable. Consider the technology in your pocket. Your smartphone's ability to connect to a cell tower or a Wi-Fi network relies on signals that travel in waves. The formulas that describe these waves and allow engineers to build systems that send and receive them accurately are filled with pi. This field, known as signal processing, is fundamental to all modern communication. From the GPS in your car calculating your location to the radio playing your favorite song, pi is the silent partner making sure the signals are clear and correct. It's the hidden language of our connected world. Pi even helps us enjoy our favorite foods. If you order a pizza, the restaurant knows that an 18-inch pizza has more than twice the area of a 12-inch pizza, and they can price it accordingly. This is because the area of a circle is calculated with the formula PR squared, where R is the radius. This simple calculation helps businesses be more efficient, and helps you decide if the large pizza is really a better deal. The same principle applies to baking a cake in a round pan, or figuring out how much soda is in a cylindrical can. Pi helps us quantify the world in practical ways. Finally, here are a few fun facts about this amazing number. Pi Day is celebrated by math enthusiasts around the world on March 14th, which matches the first 3 digits of pi. Some people even take part in pi memorization competitions to see who can recite the most digits. The current world record is over 70,000 digits. Also, because pi is irrational, it is believed to contain any and every possible number sequence you can imagine. This means that somewhere in the endless digits of pi, you could theoretically find your birthday, your phone number, or even the entire works of Shakespeare converted into code. Pi is not just a constant, it's an infinite universe of numbers.